got an enlargements question with a twist here because I've got the original shape and I've got partial information on the on the where the enlarged shape. We're told that vertex A maps to 6, 7, and we're told that vertex B maps to 2, 9. Now we're asked to find the coordinates of the center of enlargement. This can be done. I'm just going to talk about two different scenarios. Let's say I've got a center of enlargement here, and then I've got some sort of square. What I would do is I would draw ray lines that go through here, and then that would help me draw my shape. Okay, instead of going if the scale factor was 2, instead of going say 1 along and 2 up, I'd go 2 along and 4 up. I would multiply those lengths by 2. Equivalently, I would go just instead of going this distance, I would go twice the distance to get to that vertex. Now, in a similar way, if I have the shapes themselves and I wanted to get back to the center of enlargement, I could actually draw ray lines that go through the corresponding corners, and then where they meet would give me my center of enlargement, and that's essentially what I'm going to be doing here. I'm going to draw a ray line that goes between these 2 points and then between these 2 points, and there I see an intersection. It will always intersect at the center of enlargement. That's it, this point here, 10, 11. Okay, what I see then is that I've got a corresponding sides AB, and I go 1 down and 2 along. For these ones that it's mapped to, I go 2 down and 4 along. So I can see the scale factor must be 2 because it's twice as big. I'm going that distance AB, but then I'm going the same distance again. Okay, at this point, I just need to think about what kind of enlargement this is. The center of enlargement is in between the two shapes. This is going to be a negative scale factor, so that's just something to be aware of. Because now C maps onto a different point R, and I've got to draw that out. So I'm just going to kind of remind myself about how to deal with a negative scale factor, because actually I've just realized I've made a mistake. It's not 2, it's -2. If it was 2, then I would be going from the center of enlargement out towards the shape and beyond. It would be over here somewhere. But I'm going from the shape through the center of enlargement. That's what gives me -2 as the answer. Very easy to get that wrong. I nearly got that wrong there, but I've just thought about it and I've corrected it. Okay, so I can see what's going to happen. Like if I go from the blue point, then I go along 2 and down 2. And then if I multiply that by 2, I carry on going through the center of enlargement, and then I'll go along 4, sorry, down 4 and along 4, and that will get me there. So instead of 2, 2, I go through the center of enlargement and I do 4, 4. The same is similar for the red one. I go along 4 and down 1. So now I carry on and I go down 2 and along 8. And that will get me there. Which leads me to my final point then. And I'm going to get rid of these numbers now because it makes it look a bit confusing, but I'm going to do the same process for point C. Okay, here goes. For point C, I'm going to go along to the left 3, and then it's down 5. So what do I then do? I need to double it. So I'm going to carry on going 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to go here, but then I'm going to go along 6 because I need to multiply by 3. 1, 2, 3, 4, 5, 6. This is the hardest transformation, I think, but that is where I'm going to end up. R is going to be 4, 1. And we could just, I think it would help to just draw that shape. Okay, because it does look about right if I was to shade it. There's my enlarged shape. There's my original shape. You can see that it has to be a similar shape. You can see that it does look similar.